Good morning. So this session is going to be focused on correlations, okay? Pearson's correlation to be exact. So Pearson's correlation is great for when you have interval or continuous measurements, such as what we have here. We have three scores that are similar for score 2 and score 3. Except for there's one entry that's a 5. That's probably, an error, in data entry error. So let's go and try to run a correlation. So how you do that is you do analyze, correlate, bivariate. You move over scores 1, 2, and 3. You will tick Pearsons. You say okay to this. All right. And then I've already done it. So let's look at the output. So your Pearson's correlation is a matrix. And how it works is the rows will be the variables and also the columns. So it's a round robin. So score 1 will be compared to itself, which is always a 1, right? You compare anything to itself, it's a 1. All right. Score 2 to score 1 will be a correlation of 0.047 with a p-value of 0.912. Score 3 to score 1 will be negative 0.798. with a p-value of 0.018, okay? And so getting the hang of reading this matrix, you're reading the column and the respective row to get the Pearson's correlation, all right? Your p-value is the sig two-tailed, and your counts are 8. You have 8 records. Now, out of all of these correlations, the only ones that are statistically significant are score 1 and score 3. What I recommend you do is not to stop here. If you know you have a statistical significant finding, your correlation is really not enough to show or demonstrate what is going on between two variables. You really should move forward and graph what is going on. Okay, so how you would do that is you would go to, what is this thing called? Graphics. And then you would go to the scatter dot feature. And here is your graph. So here's a scatter plot. A scatter plot, you're just plotting the points between two variables. Your two variables are like coordinates. If you remember mathematics, you have an X and Y coordinate. So your X coordinate would be score 3 in this instance, and score 1 would be your Y coordinate. And if you look here, you see, yeah, the correlation was negative, right? The correlation was negative 0.798, which means that there's a very strong correlation between, it's negative, between score 1 and score 3. See how the dots tend to decrease over time along score 3, okay? Actually, I misspoke. So as score 3 is increasing, your score 1 is decreasing. You see that at 100 for score 1, your score 3 is almost to 25, right? Whereas for score 3 being equal to 5, your Y coordinate is 220. So a negative correlation suggests that one variable is increasing while the other one is decreasing. And that's what's happening here. If they were both going in the same direction, then for increasing x coordinates, your y coordinate would be increasing as well. Okay, so this is just a quick, brief video on the Pearson's correlation. And we see that score 2 and score 1 was not statistically significant at all. It's close to 0.047. Anything that is close to 0 is not going to have a pattern, pretty much, because you're essentially saying there's no relationship. Okay? So thank you for listening.